Support us by subscribing, ring the notification bell.
My name is LeWinter. I'm a research physical scientist here at the Cold Regions Research and Engineering Laboratory, and I work in the Remote Sensing GIS Center of Expertise. So my team, the LIDAR group at the Remote Sensing GIS Center of Expertise, specializes in, as you would imagine, LIDAR. LIDAR stands for Light Detection and Ranging. LIDAR uses light. Specifically, LIDAR uses very fast pulses of laser light to measure distances from the sensor to an object, and from that, by doing it really fast, we're talking millions of pulses per second, you can create a very high accuracy, high resolution, three-dimensional model of your surroundings. So mobile LIDAR is used to capture high resolution, high accuracy 3D models of large areas in a short amount of time. So for example, in the Army Corps, we're interested in some of our civil works infrastructure, levees, dams, reservoir infrastructure. In order to map those, if you were doing a traditional survey tripod setup, it's going to take you days or weeks to map an entire area. Whereas with a mobile laser scanning system or mobile LIDAR, you can drive it in a couple hours, even tens of minutes, and capture an entire area with centimeter scale accuracy and resolution. The laser scanner we have is a dual head laser scanner. So if you look up on top, there's two scanner heads, and then there's we call it like the octopus of cameras radiating out from the base. Inside of this scanner housing is the inertial measurement unit. That's mounted on top of this very tall vehicle. The higher up we are, the better the field of view, the better perspective. It's just like climbing up on top of a ladder at a concert. You'd be able to see much better than if you're stuck behind some 6'5" person. And then that control box connects to the different power sources on the vehicle, and then it also connects to the driver or operator's display. And really, it is a one-person operation. To start the system, you turn it on. You need to allow the IMU to essentially bake in and find its initial static position. As that's happening, you're checking on the scanner and the cameras and making sure they're all configured correctly. Then you do what's called a dynamic alignment, basically perturbing or moving the IMU so that it can find more precisely its attitude, its heading, its direction, and its position. And then you just start scanning. The options are kind of limitless. You can create a lot of different products, and for each project and each need, the products change depending on what the actual focus is, what the measurement is, what's the quantification that's needed.